Hi, my name is Yuris. I am the application engineer at CENOS, the affordable platform for engineering simulation. We integrate open source tools into the single user-friendly platform. Now, I would like to show you how to perform the inductive heating analysis for a billet which is moving with a constant speed. Our problem consists of one aluminum billet, copper inductor, and surrounding air. To solve this problem, first we will create 2D axisymmetric geometry, then we will generate and export mesh to CENOS. Later we will define time harmonic electromagnetic problem and define thermal problem. Later we will run the simulation and finally we will post-process our results. So let's begin with the first step. We start with clean CENOS case and add preprocessor. We select create geometry and mesh. And let's click on play button. So now CENOS will open Salome, preprocessor. When it opens, then we have to select geometry model and create a new case. So now we want to create a computational domain. For that, first we will create 4 points. We will use this point construction tool, create the first point at 0, 0 coordinates. Second point will be at x equal to 300. We click apply again. Third point will be y to 300. And the last point we change x back to 0. Click apply and close. So we created 4 points, and now we want to connect them with lines. We use this line construction tool. We click on the first point, second point, and click apply. Third point, apply. Fourth, and again the first one to create a closed line. Now we will select all 4 lines, and we will use this tool called build face to create a computational domain. So the next step now is going to be to create this billet and copper inductor. To create a billet, what we need to do is just split this computational domain in 2 parts, and we will do it with line. But first, to create a line, we have to create points. So first point will be at x equal to 30. Because 30 millimeters is radius of our billet. We click apply. Then we will change y to 300 because 300 millimeters is height of our computational domain. We click apply and close. Now we will connect those points with line. We select the first, the second. So later, when we will create a partition, then this line will divide this computational domain in 2 parts. Now we want to create a geometry for copper inductor. Thereby we again create 4 points. The first point will be at x equal to 40 millimeters and y equal to 100 millimeters. We click apply. Next point will be at x equal to 60 millimeters. Then the third point we change y to 150. And finally we change x to 40. Now we will connect those points with lines. And when it's done, then we can create a partition. So I select all lines and computational domain and go to operations and partition. I click apply and close, and now this partition is one piece which consists of billet, copper inductor and air. But still CENOS will not know the names for those bodies here and for boundaries. Thereby we have to create a geometry groups for this partition. We click on partition and go to new entity, group, and create a group. First we will create a groups for bodies. We click on this surface shape and select our billet. Then I will add it and I will specify the name. I will call it billet. I click apply, and now if you will look here in partition dropdown, you will see that billet was added as a group to our partition. So the next step we will click on copper, inductor, click add, I will call it inductor, and click apply. And the same way for air, I click on air, add it, name it, and click apply. Now we want to create boundary conditions. Thereby we will use this edge tool here, edge shape type for edges. First we will select this axis for billet. I will click add and name it billet axis. Next, we want to create those two surfaces, boundaries here for billet that are outer boundaries. I add them, and we will call them billet out. And the last surface, the last boundary condition for billet is going to be this for heat exchange. We add it, and we will name it heat loss. So there is one boundary condition missing, is this one, far field for air, so we have to also add it. I hold shift and click on those three edges, then I add them, and we will call them far field. Let's apply and close this window. So as you can see that we now created a geometry for billet, copper inductor and air, and geometry groups for bodies and for boundary conditions. So in the next part of this tutorial we are going to match this geometry and export it to CENOS. Thank you.